Now we're going to apply what we've just learned in order to solve the problem we started with. We'll begin by finding the vertical components of our vector C. We'll find the vertical components first of our wind speed, then of our airspeed. I'm going to start with the vertical component of B, which is the wind speed, and move it over here. And likewise, I'm going to take the vertical component of our airspeed, move it over. And those together make the vertical component of C, the overall resultant we're trying to find. As far as the horizontal, we're going to start with the horizontal component of the wind speed, then add the horizontal component of the airspeed. Those two lie along the x-axis. You can see that since they're both positive, both pointing to the east, they're going to add up together to make horizontal component of our desired resultant vector. Okay, for our own sake, visually, we're moving the vertical components over to become the opposite side of this vector diagram, which is going to look a lot like a triangle. And then we can draw in our hypotenuse. And now you see that our resultant here, which we're calling C, it has its y component, which is the sum of the y components of the two original vectors, and its x component, which is the sum of the two x components of the original vectors. And we're going to be able to do Pythagorean theorem to find C. Also, the direction of the new vector can be found as the inverse tangent of the opposite side divided by the adjacent side. The opposite side is our vertical side, the way we've drawn it, and that's the way it's preferred. And our adjacent side is the horizontal side, the way we've drawn it. And notice our original trig function was tangent of theta equals opposite over adjacent. We didn't want tangent of theta, we want the actual direction, the theta itself, the angle. So we had to get rid of that, we had to detach the tangent part from tangent theta. And to do that, we had to take the inverse of that function, just like you do in algebra. You always take the inverse in order to eliminate a certain, to cancel a certain term. The inverse of tangent is, of course, the inverse tangent. And we take that, we do that to both sides. And so the inverse of tangent multiplied by, or taken of tangent, cancels tangent. And on the right side, we end up inverse tangent of opposite over adjacent side lengths. Alright, here's a restatement of that, just showing that the sum of the vertical components from our originals equals the vertical component of our resultant, and the sum of the horizontal components equals the horizontal component of our resultant. Alright, let's do the math. So our airspeed was 45 meters per second. When we multiply it by the cosine of the angle, we'll get how much of it was in the horizontal direction. Our airspeed in the horizontal direction was 15.4 meters per second to the east, and that's why it's positive. And for the wind speed, its angle is 20 degrees relative to due east, and so we take cosine of that 20 degrees multiplied by the 54 meters per second. We get 50.7 meters per second in the due east direction. As far as vertical components, we have still for airspeed 70 degrees was our angle, but we have to take the sine to find the vertical component. Sine of that angle times 45 meters per second gives us our 42.3 meters per second from the airspeed component. And our wind speed component, we're using again the angle 20 degrees, but we're taking the sine of it to find the vertical part. And so sine, or the northward part, sine of 20 degrees times 54 is 18.5 meters per second, and so we can fill in our drawing here with all the values that we've just computed. These are the values from the previous slide. You can see that they add up to 60.8 meters per second in the northward direction, and then in the eastward direction we have 50.7 meters per second for the wind speed and 15.4 meters per second for the airspeed, which gives us a total of 66.1 meters per second in the due east direction. And of course, when you set these up, you can see we have our two sides of we have our base and our height, or our two sides, two legs of a right triangle, and we'll find the hypotenuse by squaring these two numbers and taking the square of the sum of those squares. So there we go. There are two. This is our horizontal component. This is our vertical component. and we're squaring them and taking the square root, and that gives us an overall speed of 89.1 meters per second along the ground in the direction that we're traveling. As we said, we could tell this is going to be less than 99 and it was going to be more than 9. Turns out it's in a sort of a northwest direction, but you can't just say northwest because it's not exactly at 45 degrees, or sorry, northeast direction. You can't just say northeast because northeast is exactly 45 degrees north of due east. And this is not exactly 45 degrees. If it had been, we'd have equal speeds in the eastward direction and in the northward direction. You can tell by looking at this, since we're going a little faster to the east than we are to the north, our angle should be less than 45 degrees. And indeed, we're going to go ahead and calculate that. As we said before, we're going to plug in our two lengths, our opposite. Our northward component was 60.8 meters per second. Our eastward component was 66.1 meters per second. When you plug those in and take the inverse tangent, you get 42.6 degrees, and it agrees with what we would have expected for our calculation. I hope this example has helped. We'll just go ahead and replace these on our original kind of graphical depiction. And so there you go. You've got your 89.8 meters per second is the magnitude of this resultant vector, the blue one, and our angle we've now found it to be 42.6 degrees.